Are you a good programmer? Who is a good programmer? Someone who writes very beautiful code, well indented, spaces used in the right way, functions names, variable names, classes names, all as per convention. But does that qualify someone to be a good programmer? I don't think so. Then who is a good programmer? Is it someone who uses interfaces, abstractions, polymorphism, all the nice architectural patterns, design patterns used the right way? Is that then make someone to qualify as a good programmer? I think these all things are important, maybe non-negotiable. But I still believe this is not what would define someone to be a good programmer. Then how do we define, how do we classify, how do we say that someone is a good programmer and someone is not? Let me give an example. Suppose, let's say I give you a car, very beautiful car, metallic body, interior done to world-class experience, leather upholstery, all good things inside it. The only problem is you can't drive that car. It can sit in your museum piece, but you can't use it as a vehicle to drive from one place to another place. Would you consider it to be a good car? I guess not. Because the basic purpose of a car is to transport, is to take you from one place to another place. Without that, it's not even meaningful to say that that is a car. Hopefully that would be giving you some clue about when I say that who is a good programmer. So basically on the same lines, a good programmer is one who is writing programs, codes, systems that serves the business need, the need of the customer. Otherwise everything else is fancy. So then how do we define someone to be a good programmer? I would say that then a good programmer is someone who basically understands the need of the business, the need of the customer, and builds the system to serve that need. Anything less than that, I would debate that doesn't qualify it to be in the category of the good programmer. But why this need of understanding the business requirements and all rests with the programmer also? We know that there is this whole discipline of product management whose whole purpose is to understand the business requirement, understand the customer requirements, and provide it to the programmer to code it. Fair enough. But let me give you an analogy from another industry, and then we'll come to the point that why it is very important in the software world for a programmer to understand the business requirements, the customer requirements. Let's take an example of construction industry. An architect designs the house, and then they translate their vision, what they want to achieve in terms of drawings. And then there are well-established processes and techniques in that industry. The details are nailed down to the last decimals. There is very less scope of ambiguity when it is handed over to the construction workers. However, when we come to the software world, the situation is little different. It's still a very nascent industry. Still, there are not enough processes, tools, techniques through which the requirements as needed by the customer or the market translated to the products and then further translated so that it can be communicated to the developers or programmers in an unambiguous way. That's why it becomes very important that there should be an attitude and an aptitude from the programmers, from the developer side, to basically try to bridge that gap coming from their own side. So they should strive to understand what exactly is the requirement that they are solving. Otherwise, it becomes very difficult, and what would happen is that you might intend to build something which was supposed to go to moon and it might land up in Mars. Elon Musk might be happy, but not your manager and definitely not the customers. Then there is another aspect as well. Again, coming back to the construction industry, what happens is that the moment first brick is laid, it's easy to visualize People can see what is coming up. Construction workers can see, architects can see, and other stakeholders can see. So at very early stage itself, it starts showing up that how the formation is coming along, and it's very easy to do the course correction if people found any mistake. This is very different in the software world. A lot of code goes in before a first tangible set of piece can be brought into picture, which can be shared with others. Then it becomes a big problem because the mental model that the programmer or coder might be carrying would be very, very different from what a customer would be eventually needing. And if there is a team of, say, couple of developers, it is very common to see that each one also have their own mental models they are carrying with and building the things. So from that perspective also, it becomes very important that the programmers and the developers have the initiative to strive and go forward and understand the requirements and make sure that that is what is getting captured into the code pieces that they are writing. Of course, then there are other issues of under engineering and over engineering. We will touch on those topics in one of the other videos. And thanks for watching it through. See you next time.